All right, good afternoon, good morning to some of you. Welcome to today's session on how Tableau can help manufacturing companies build a data-driven culture. Today's session is being recorded and will be emailed out after the session. Please submit questions in the chat window and we'll address those at the end of the session. Next slide, please. So you might be wondering who you'll be hearing from today. My name is Joe Niewiadomski. I head up Keyrus's Tableau partnership here in the East, and I'm joined by Raz Nister, who leads our data science team here at Keyrus. Just a bit of background and context. Keyrus is a global data and analytics consultancy with offices around the US and Canada. We are a Tableau Gold partner, which means we specialize in helping Tableau users such as yourselves realize and maximize the value you get from your data assets. And that's really aimed at positively impacting your business. Oftentimes that takes the form of providing services to optimize the efficiency and governance of your data processes, providing training and resources for visualization best practices with Tableau, which will be a major focus of today, and incorporating advanced analytics into your everyday business processes, which we'll also touch on today. Today's session is going to highlight the utilization of Tableau for supply chain and operations within the manufacturing world, and we'll also touch on some predictive analytics. The aim is to demonstrate the art of the possible with Tableau in the manufacturing space. So with that, I'd like to turn it over to Raz, who will jump into today's content. Take it away, Raz.
Thank you, Joe. Thank you, everyone, for joining us here today. Very happy to have you all on the call. I hope everyone is safe and doing well. Hope the country continues to open up and we could get back to business as usual and get the manufacturing industry especially roaring again. We're going to be walking you through a few use cases and examples of the type of work that, that we've come across. But before we do that, I just wanted to sort of set the stage. We often show this slide. It was sort of the way things were done maybe about 2 years ago in how we would help organizations along their sort of what we call now their AI journey or their tactical AI journey. A lot of organizations in manufacturing and other industries very much here at the beginning stages of their sort of analytics journey, starting with raw data, maybe cleaning some reports, doing a lot of Excel stuff. And what we would traditionally do is build out a roadmap to really enable these organizations to become data-driven. Tableau is a tool that would be an integral component of that. We'll talk why in a second, and hopefully you can see through the examples. But the journey was essentially like very concurrent. So one step after the other, we'd get reports, we'd get self-service BI, and then we'd 18 months down the road, move into the tactical AI use cases. But things have shifted, and this has been going on for a while. We know data science is very popular. Becoming AI-driven is very much a keyword nowadays. And the reason is a lot of the questions and the value that organizations can unlock from their data usually involves a little bit more advanced analytics approaches and sort of asks questions that really drive the bottom line. And Tableau is a tool where we can sort of get to this picture where we can start to answer some of these deeper questions using some advanced analytics or AI much earlier in the process. And what we end up is with this sort of this dual roadmap or this dual approach, where we still have a very important sort of operational reporting side. Of course, we still need to understand how the organization is doing every day, every month versus plan versus last year versus competitors. But what we can start doing is unlocking some of the insights that will return higher value for the business earlier on in the process. And manufacturing is a key sector, I think, ready for some of this. The reason is if you look at how manufacturers go to market, they have a very rich supply chain. They purchase materials, raw products, commodities from suppliers, from the markets. They have to go through a very extensive procurement process to do that. They get those materials, they actually make something. There's a lot of engineering, innovation that goes on into this process. Once they have a product, they have to ship it out to people, to consumers. There's a whole distribution channel. And maybe before it even gets down to a customer or an account, has to go through sort of various sales processes. So it's a very rich supply chain, value chain process where along each one of these points, there's many use cases where a tactical AI approach can be used to leverage and gain optimizations. And by tactical AI, I really mean answering like very insightful business questions. I think questions that have been around for a long time, like how is my marketing, returning my investments and affecting my sales? Like that's a very sort of standard question in marketing. We can answer that a lot better now. I think we have a lot better machinery, give us more realistic planning options and capabilities to answer some of these insights. And in manufacturing, it comes down to, how can I better organize my supply chain or optimize my costs on freight and materials? How can I understand when my machinery is at risk of failing, of causing downtime, which costs me thousands of dollars, an hour, and thousands of dollars in repairs to sort of get up. These are standard questions, and we want to go through and answer some of these here today. And we'll see how exposing the answers through a visualization tool like Tableau can make the transition from data to information to actionable insights very apparent and fluid and natural. So in the market, manufacturing is still a core component of the US economy. If we take a look at the firmographic landscape compiled by the Department of Labor, essentially the US is a services dominated industry. Companies under the services branch sort of make up 26% of the economy. But about a very close second is manufacturing. It's still a very core component of the US market. And if you look at some of the sub-industries under manufacturing, we have things like petroleum and refinement, chemical companies, industrial commercial machinery, food, kindred products, electronics, transportation, so on and so forth. You might think some of these are almost sound like CPG retail companies, and it's true. They have a very similar sort of value and supply chain. But I think here the focus will be on, optimizing the production process and bringing products to market. Sorry, 1 second. Okay. So what we're going to go through is some demos now to highlight how we can use Tableau to sort of become data-driven. And like I said, I hope through the examples you realize how properly engineered dashboards can expose the right level of insights and information, to actually lead to actionable steps. So we're going to go through a few examples, and hopefully by the end we'll have a clear picture of how all this works in practice. I'm just going to stop sharing my screen and reshare so that you can see my dashboards. Give that a second to come up. Okay, all of this is available on the Tableau public site of Keyrus. If you go to public.tableau.com, just search for Keyrus and look for the site with the circular logo. You'll find all of these. We have our very first sort of landing page as our feature, which is can sort of walk you through some of the examples and use cases that we have up on the site from different business domains, strategy, marketing, sales, supply chain, so on and so forth. But today we'll be focusing particularly on the manufacturing side of things. So let's go into our first dashboard. This is representative of an operational level dashboard for a manufacturing company, in this case, Wainwright & Sons, which produces custom housing and control arms for vehicles and things like that. And we want to walk through some of the ways we've seen data be used to understand how the company is doing on a daily basis. Some of the KPIs that are a little bit more than just how many parts we produced. Some of the data consolidation behind the scenes here really starts to sort of speak to what is a sort of net profit picture, or what we call contribution margin picture, where we really understand how much are we making per part. Where are the gaps? Where are the gaps in efficiencies? How can we address these? Because if we turn everything into a dollar margin, then it becomes very apparent we're actually on the right track or not. So this is a typical operational dashboard. This is just for sort of today's date. We have a live sort of picture of what's happening in the plant. In the middle here, you can see that our production line is sort of composed of 1, 2, 3, 4, 5, 6, 7 sort of stations. Each station is producing some or one key parts, a lower arm, upper arm housing, or screw assembly. Each station is operated by a particular individual, and each station is sort of running on its own, and during this process, collecting the data and compiling this information. The data collection and consolidation that's happening in the back end that leads to sort of some of these KPIs, which we'll mention in a second, is actually pretty involved these days. It's not just so much getting some transactional stream of data maybe stored in some clunky old ERP system or something, although that is still around and a key component. A lot of data these days is housed and stored in multiple systems. Sort of back-end like Tableau prep allows analyst level people very easily to sort of connect to multiple systems and bring data in together. And what we're particularly interested in is things like, yes, sort of my number of parts that I produced. What is my target for the day? What is my operational plan? Yes, this is all very important. How are the machines doing in terms of coolant and RPM levels, things like that. But converting things into dollar amounts, like I said. So per part, I sort of have an idea of what my profit margin is, my gross profit margin. And sometimes it's not easy to get to, but in most cases, we work a lot to sort of bring in and understand how our pricing and our sales converts part numbers into revenues. And then also how we can bring in a component, which is sometimes tied to our operational cost, which sometimes includes our promotional and marketing side of things, but is essentially a variable cost component. Things outside of like, our plant rental fees, which are pretty consistent throughout the years, but a variable cost component that really gives us a picture of what our net profit margins are. And this is called contribution margin. If you take your sort of sales, your revenue minus your variable costs, divide by the number of parts, you sort of get a dollar amount called contribution margin per part, which tells you how much money you're effectively making on the floor. And this is really kind of the, made possible by a lot of that data consolidation on the back end. So if I was very interested in what's happening on the floor today, I have this operational level dashboard with some charts, with some sort of custom color maps here that could tell me, very quickly, like if I just look at a key metric, like number of parts, how am I doing and which sort of line or machine in the production line is producing the most parts. Turns out it's number 7, producing screws, probably because, screws are easy to make, so I make a lot of them per minute. I could take a look and see how I'm doing versus my plan, my delta to target, am I lagging anywhere? I am a little bit behind. Machines 1, 2, and 3 are about 1 part behind. So I have to take a look at that. And it looks like the operator, the sole operator operating machines 1, 2, and 3 is this poor fellow, Szymanski. And he's about three parts off target. So maybe that's something I should look into. I could take a look at, for example, idle time of my machines in the plant. I could see that, not everything sort of runs automatically each step. There's probably some gap in between production flows. But I could see that machines 6 and 7 actually have a lot of idle time. Maybe I was expecting Szymanski, this poor fellow, operating multiple machines here in the corner. If I click on his name, I could kind of zero in and see what he's doing. So there's one guy, this poor guy operating 4 machines here, poor guy. I would have expected a lot of idle time to be popping up on those machines, but in fact, that's not what I'm seeing. I'm seeing idle time on 6 and 7. And from this graph, I'm also seeing that, you know, a pretty big component of idle time is actually fault time. So something's failing in the process. And I could zero in on fault time specifically just to see and understand where my key gaps are. So I do see that, okay, here's Szymanski again. Machine number 1's having some issues. That's for sure. In total, we're about 432 minutes of fault time. It's quite a bit across our production line. So we gotta think and understand what's going on. But I also see I have some heavy fault times in 6 and 7. And if I really want to get to this contribution margin picture, since all the data is connected underneath the hood, I can understand now, you know, where's my sort of money, my net profit coming from on the production line live with this data. And I could see that, you know, Szymanski, this poor fellow, again, is not doing too badly. I actually do have a gap here in machine 6 and 7. And, you know, I could zero in and sort of filter on just those machines in particular and see that it's these two people, Mr. and Mrs. Wright, Mr. Benedict, sort of struggling a little bit. And out of the two, I think our screw assembly is sort of not producing as much profit per product as we, you know, as the other parts. That may be okay because screws, to be honest, there's probably not a lot of margin on them. Other things I could do though to sort of try and deep dive into the situation happening here, to try and understand what's going on with 6 and 7, is sort of take a look at the efficiency of my processes. So how much fault time as a function of total production time is going on. And I could see that, yeah, there's definitely something going on with 6 and 7. They're just not as efficient as the other processes. And if I look at how that affects my contribution margin per minute, then I also see there's a huge gap at number 7. So if I'm really trying to convert and understand how gaps in production, like realistic gaps in production, affect my bottom line, then I can do that if my data is all connected underneath the hood. And I could go see what Mr. Benedict is doing to understand what's happening with this line. And generally when we do this, we find that the workers are working very hard. Actually, there's just some problem in the production process, or the machines are, you know, requiring lots of maintenance. So that leads us sort of to our next capability of the dashboard, which is, you know, if I could better sort of predict these downtimes, you know, maybe I could tighten things up a little bit and support, you know, my production process, make sure I hit my targets while mitigating and minimizing the risks to the sort of the machine. So this comes into the form of a predictive maintenance dashboard. And what we've done here is sort of take a look at, for example, like a CNC lathe machine that you see here. And from the factory floor, we could get a lot of sort of data feeds in from this machine. A lot of these machines are getting smarter and smarter. Internet of Things is happening. So you could get a lot of almost real-time streams of what's going on. And if I take a look at just one of these machines, I could see that, you know, throughout a 3-month process, I do have like these faults, these downtimes that happen. And I'm curious if there's like some data, some signals from the machine that could allow me to predict when these will happen so I can mitigate the risks. Things that, you know, we get out, some of these signals, things like related to the motor, essentially voltage, amperage, like how much power put on the motor, really driving, you know, the amps up to get extra torque. That could affect sort of the reliability. The cutting fluid, the oil, sort of going into the lathing process is very important. So essentially, you know, what's the pressure? How much liquid are we getting in there? Things like that. How much coolant is very important. And inside the chamber, we have like actuators, spindle belts, and all types of things, which could tell us if the actuators are working too hard, and maybe the armatures and the motors are sort of overheating. And I could get these signals out. So for example, I could get like an amperage sort of signal where relative to an average, I sometimes see these spikes. And I start wondering if these spikes correlate to some of these fault times. Like, see, not really. It's not so clear one-to-one, right? What about if I add, like, you know, the voltages in place, see some of these spikes? Maybe. I have a spike here, sort of maybe aligns with some of these here. Oil pressure, sort of measurements, kind of pretty consistent across the board. Oil temperature, right? Um, Chamber temp or actuator temperature on the armatures of the motor. Not sure. Maybe some of these in combination sort of lead to some of these, some of these faults. It's clearly not a problem I could solve by eye. And humans are good at sort of picking out 3 or 4 sort of things that look correlated and coming up with a sort of heuristic explanation of things. But here, we could apply a little bit more serious methodology in the form of machine learning to try to predict how some of these signals across the board lead to some of these faults. And we've done that. We've essentially constructed a model that can take any input signal from the machine and predict whether a fault will occur in sort of the next 5-hour time frame. And the results of that model, the modeling is here. So for example, if I plot the number of faults or downtime over the 3-month period, I get this gray line. And you can see that our model is sort of way overstated. And the reason for that is really because I had to convert it into something simplistic for Tableau Online. So I take a look at my model. That equation down at the bottom is really a linear model, which is not enough for this. So we sort of had to parameterize it and give it a little heuristic boost with a threshold that we came up with. And my first job is to sort of see if I can use this little fudge factor to sort of take my machine learning model and kind of heuristically get it to fit the data a little bit more cleanly. And if I bump up sort of a little bias in the model, I could see, you know what, it's not too bad. I could sort of get a model that kind of accurately sort of follows and predicts the actual fault time over the 3-month period. And what I really want to know, for example, is, my fault rate is pretty low. I mean, out of the 3-month period, I have thousands of hours. I only had like 3% downtime. Maybe that's acceptable. We want to see if we can lower that essentially by easing up on some of the input signals from the machine, while at the same time not affecting our production. So in this sort of time frame, we produced 2,300 units at a fault rate of 3%. But can I tweak some of the motor voltages and some of the oil temperatures and things like that so as to lower the fault rate, but even maybe increase the unit production? That's really what we want to get to here today. And we've exposed that here via some sliders, which is very nice and easy to do in Tableau. This is one of the key features that I think makes realizing these advanced analytics use cases come to life. So for example, if I take sort of a little bit of oomph out of the actuator parts, out of the chamber mechanics, you can see I can lower essentially my temperature. And really what I'm doing is playing with like sort of voltage parameters here, in effect lowering the motor temperatures. And if I lower it, what you can see is that I do in fact get a much lower sort of predicted fault rate. Sure, I took out a little bit, I'm not using it as aggressively, so sure, it's gonna not fault so much, but I'm correspondingly also dropping units. And that's not exactly what I want to do. So I want to see if I could come up with a mixture of parameters that, for example, can lower slightly the fault rate, but keep the level of production sort of steady and going. And this what if analysis I'm doing on the fly here, this is exposed via the dashboards. It's sort of like a poor man's web application that we tied together here underneath the hood to sort of show the capabilities of how you can really gain insights from the way things are interconnected via these models in a dashboard sort of setting. And you can see that I can actually get to a case where I can lower the fault rate slightly. Maybe 0.12% is not that big. But if I take a little oomph out of the actuator side and invest a little bit more on the motor side, the driving motors or the drill bits, increase the amperage and voltage, or give them a little bit more power, more torque, I could actually like improve my performance by like 4%. So imagine going to your manager, 4% margin in production probably leads to, a couple, tens of thousands of bucks over this time period, no problem. And this is like free money. So this is the type of thing we're trying to understand from our IoT data. What can we do to improve our processes? And this is really sort of a place, I think, in the interest of time, that I want to sort of pause and let this sink in, that the dashboard becomes a place for lively engagement with the data, interactive engagement with the data. And by playing around and exploring these what if scenarios, that's how we sort of develop insights and get to a data-driven culture, because we can now have a channel to ask relevant questions and answer them via this sort of slick user interface presented here. So Joe, I think I'll pause there and pass it back to you if we want to wrap it up with some questions and final thoughts.
Yeah, thanks, Raz. We actually do have one question, and it's in reference to this, this dashboard that you happen to have up on the screen. The question is, can you talk about what a parameter is and the role that it plays in advanced analytics in a model such as you're displaying here?
Absolutely, good question. So Tableau has these the capability to build parameters on the fly on the front end, which I think is a distinguishing feature in the BI space. And what it allows me to do is take an input into a model, say like motor voltage or cab voltage listed here. And instead of just putting, you know, its actual value, it allows me to scale it in some way. So I could say, you know what, as I start to crank this thing up, don't just put the actual value of that voltage, say for the next time period, into the model so I could get a response, multiply it by 1.1, give it 10% little boost. And that's how I use parameters to sort of drive and enable this what if analysis, is by slightly tweaking essentially the inputs of the dependent variables that we put into the model, allows us to expose these types of sort of insights. And that's what is a key driver of this what if sort of analysis. And I have to say, like, this is most smoothly done on the Tableau side. Tableau is very good and very easy to come up with and sort of code out these parameters and calculations. And what it's effectively doing, like I said, inside this little question mark, you see that equation at the bottom, that cab voltage, maybe that third line down, is actually multiplied out by the cab voltage param. That's where you see it effectively sort of smudging the expected value a little bit and asking of the model, you know, just tweak it a little bit and tell me what happens. That's how these things are driven.
Great, thanks, Raz. We actually have one more question here. It's in regards to access to the dashboards. The question is, are you able to restrict access to different people, to the dashboards, components of the dashboards, et cetera?
Yeah, absolutely. So on Tableau Public, you can see everything because it's open. On your own instance of Tableau Server or Tableau Online, you can control very tightly who can see and do what, who can only interact with the data, who can modify reports and download things, who can publish new reports of new data sources up. So I think that's a pretty streamlined sort of process and setup on the Tableau server and maintenance side of things. So absolutely, you can control definitely that via even how sites and projects are constructed, but more specifically down to even what an individual user can and cannot do.
Great. That's all for the questions. Raz, if you could go back to the slide deck, we'll wrap things up here. Great, so thanks everybody again for joining. Just wanted to highlight that we, Keyrus, are here to help. So if you're looking to discuss any particular challenges regarding your data sources, Tableau best practices, advanced analytics, or really anything in between, please feel free to reach out to us. We'll also send along our information as well as a link to this call for your reference, and we look forward to connecting in the future. Thanks everybody, and have a great day.
Thank you.